Good morning, students. Welcome back to YouTube channel SchoolQuizz.com. As you know, my name is Danish Agarwal. As we have started our chapter number 2, that is matter around us pure, and today we will discuss our technique, that is distillation and as well as fractional distillation. So let's start. That is chapter number 2. Chapter number 2, that is matter around us pure. Is matter around us pure, in which we will discuss our technique, that is first of all we will discuss distillation. So for which we use our distillation technique, we use it for separation of two miscible liquids. Separation of two miscible liquids. Separation of two miscible liquids. Miscible liquids means which can mix together. We have used our, if we want to like separate our immiscible liquids, we have used our technique, that is separating funnel. But if we want to use our miscible liquids, separate our miscible liquids, we will use distillation. So where it is based on the difference in boiling point. It is based on the difference in boiling point, which is greater than 25 degree Celsius, which should be greater than 25 degree Celsius. We can also regard it as simple distillation. If the temperature less than is 25 degree Celsius, then we will use our fractional distillation. So we will discuss our both topics, distillation and fractional distillation. It is both based on the separation of miscible liquids, but it depends that if temperature is greater than 25 degrees Celsius or less than 25 degrees Celsius. If it is greater than 25 degrees Celsius, then we will use our simple distillation, and if the difference is less than, boiling point difference is less than 25 degrees Celsius, then we will use our fractional distillation. So first of all, we will start our distillation based on a difference in the boiling point less than 25 degree Celsius. So we can write it as, if liquids in the mixture are miscible, if liquids in a mixture are miscible, boil without decomposition, and possess different boiling points and possess different boiling point then they can be separated by distillation. How we can do so? We will take our flask. In which we will take our mixtures. Like if we take our mixture, which one is for acetone and water. As we know, acetone's boiling point is 56 degrees Celsius and water boiling point is 100 degrees Celsius. So we will provide it heat by the burner. We will heat it with the help of burner. This one is our stand. This one is our cork. So we will attach it with the help of condenser. To get it condensed. So what happens when vapors form? They will pass out from there. Suppose if we supply heat, first of all, which temperature comes? First of all, temperature comes out to be 56 degree Celsius. And just when 56 degree Celsius temperature comes, acetone rises up. converted into gaseous form and rises up, and we will place a condenser here in which cool water is there, and we will attach a beaker here. So when it will come through this, it gets condensed and comes in the liquid form, and we will collect all the AC tone, and we will remove that beaker and again provide heat and temperature comes out to be 100 degrees Celsius, and we will heat till its temperature comes out to be 100 degrees Celsius, and acetone was removed, and now we will again place our beaker, and when 100 degrees Celsius comes, water rises up and gets condensed here, and we will collect all the water here, and with the help of that we can separate our acetone and water, or we can say that separate our two mixtures whose boiling point is less than 25 degrees Celsius, less than 25, or whose boiling point difference is greater than 25 degrees Celsius. But if the temperature is less than 25 degrees Celsius, temperature difference is less than 25 degrees Celsius, then we can use fractional distillation. Then will we use fractional distillation if temperature difference is less than 25 degrees Celsius. As we know, word fraction means like difference is less. Fraction means difference is less. So in which we will add our fractional, one thing more, that is fractional column. Fractional column, in which what is, like if we take a mixture and we will provide heat from bottom, and we will place a fractional column here. We will place a fractional column here in which beads are there, and then there is a condenser, and here is a beaker. There is a condenser and here is a beaker. Suppose we will take our two liquids A and B, whose boiling point is less than 25 degrees Celsius, or less than 25 Kelvin, So suppose if we take the first difference point is 65 degrees Celsius and the other one is 70 degrees Celsius. So what will we do? We will heat it at 70 degree, like 75 degrees Celsius. Suppose we will heat it like at 75 degrees Celsius. When vapor comes, both type of vapor comes. Like what? Like 65 as well as 75 degrees Celsius. Like black one is of 65 degrees Celsius and red one is of 70 degrees Celsius. And whose temperatures? This is a fractional column. Whose boiling point is 65 degrees Celsius. Its vapor has more energy, and they will overcome this and pass through this and gets converted here. Like we will get here 65 degrees Celsius liquid, we will get here that liquid whose boiling point is 65 degrees Celsius, and whose boiling point is 70 degrees Celsius. They have less energy. When they rise up, they get condensed here. And again come back into the liquid, and when all this gets separated out, we will provide more heat, and this 70 degrees Celsius will get more energy, and they will pass through this and gets condensed here and gets collected at here. So this is all about our technique, distillation and fractional distillation. In distillation, what will we do? we will take our two miscible liquids whose boiling point difference is greater than 25 degrees Celsius, and what will we do? We will provide it heat from the bottom and their vapors rises. Whose boiling point is less than the other, whose boiling point is less, its vapor form earlier as compared to other, and we will condense it and gets separated out, and we will provide further another heat, and then we will separate the second liquid out. And in case of fractional distillation, we will add one thing more. We will provide a fractional column in which beads are there. So we will whose boiling point difference is less than 25 Kelvin, and when we will heat it, like whose boiling point is less, they will have more kinetic energy and they will overcome the fractional column and get separated out, and whose boiling point difference is more as compared to the other, whose these particles gets condensed here and comes back into the bottom again. When we will get all this separated out, whose boiling point is less, then we will again provide heat and they will overcome that, and we will get separate our second one also. So with the help of that, we can separate our two miscible liquids, and we will write just one two applications more. We can use it example, like in example, separation of different gases from air, separation of different gases from air, different fraction from petroleum products, different fraction from petroleum products, etc. Fractional column is just nothing. It is we will just fractional column just nothing. We will just place here glass beads. Due to which they get condensed here and again back into the flask. So this is all about for today's topic, that is distillation and fractional distillation. So thank you very much, students. Thank you very much.